All right, so the next part of our unit, we are just dealt with percent, and we're going to use that because we're going to do something called simple probability. We're going to do a whole thing about probability, but we're going to start off with simple probability. And in that, we're going to go through some definitions like experiment, outcome, sample space, what all those things mean. And so an experiment, let's see if I can fit it in here, is an investigation or a procedure with varying results. Something happens and we don't know exactly what the outcomes may be. Well, we'll get to outcomes. I guess I give an example. A procedure or an investigation is simple like flipping a coin because different results can happen. In fact, we can have different outcomes, as I was using that word. And so for an outcome is a possible result from the investigation, experiment, if you will, procedure, whatever you did. These are the possible results. Now, when we are flipping a coin, there is two outcomes for a regular coin. And that would be you could have heads or tails. All right, so the experiment is flipping a coin. The outcomes are heads and tails. There's two of them. All right, now the sample space is the set of all possible outcomes. So in this case, like I already said, there is two of them, and typically the little math symbols we use, a little squiggly bracket here, and in this case we have heads and tails. So those are our sample space because those are all our possible outcomes. All right, so an outcome is just something that can happen. Our sample space is listing all the possible outcomes. And so I got some examples here. Some of them are good, some of them are bad here. So give the sample space and a number of outcomes for each experiment. And a little Americana for you, because to be honest with you, Canada doesn't have enough territories or provinces to do something like this. But a state that begins with the letter O is chosen. I'm a big football fan, so that's why I kind of chose this question. And so if I look at the sample space, and I don't expect you to know American states, but Ohio is a state that starts with the letter O. I had to look this up, by the way, because I guessed these three that I'm going to come up with because they have good football teams. But we have Oklahoma and Oregon. And that is the only states that start with the letter O. And of course, the only province that starts with the letter or territory is Ontario. But in our case, in this, for the amount of states that begin with the letter O, we have three in our sample space. When we look at a day of the week is chosen. Well, in this case, again, I'm going to use my squiggly brackets here. Well, we have Monday, Tuesday. It's a possibility. Wednesday, Thursday, Friday, and of course, let's go with Saturday and Sunday. Do little short forms here. Let's shrink this up. We got Monday, Tuesday, Wednesday, Thursday, and Friday, Saturday, Sunday. And then, of course, how many possible outcomes are there? 7. All right, so that is our sample space. That is how many outcomes you can have. Now, probability, because that's why we need to know these number of our sample space. Now, a measure of the chance that something, or chance, I should put, fill this in, of a specific event occurring is denoted as P with a bracket capital E. Now, the E just stands for the probability, or the P stands for probability, and the E is that event will happen. And again, the event is what you're looking for. What could possibly happen? Now, these probabilities can be expressed as a ratio of favorable outcomes. I'm going to explain this sentence. Favorable outcomes to the number, or the total number of outcomes. This ratio can be represented, now this is key for us, as a fraction, a decimal, and then, of course, finally, or a percent. Now, I want to go over this a little bit. Again, a probability is a measure of the chance of a specific event occurring, noted as probability of that event. Now, it's expressed as a ratio. Now, we won't do that, of favorable outcomes to the total number of outcomes. So what we're going to make, because every ratio can be a fraction, and we're going to make that ratio a fraction, just like we did with trigonometry. And then we're going to turn that fraction from a decimal and then to a percent, hence why we did percent earlier. All right, now we're going to do a lot of that, so I'll go through that. Now, the sum of all probabilities in a sample space is equal to just simply 1. So all the probabilities, as when you add up the decimals, will equal 1. When you add up the percents, it will add up to 100%. Just like when we flip that coin, there's 50% chance that it's going to be heads, a 50% chance it's going to be tails. You add those together, the sum, you get 100%. All right. Or there is, you could look at it as a fraction. There's a half a chance that heads happens. There's a half a chance that tails happens. 2 halves give you 1. All right. Now, some examples. Give the probability as a fraction. We're going to stick without simple form, and we're not going to go with a decimal. So we're going to give each probability as a fraction and as a percent. All right, so we have number 3 here. The spinner below is used in a game. If it is spun once, find each probability. Now, you can see our notation here. It says the probability, P, well, we'll start off. It says P with brackets of a 9. And what that is saying is, what is the probability you get a 9? Now, I look at this spinner, and there is 16 possible places that spinner could land on. So what I'm going to do is write a fraction out where I have the possibility of the event happening, or the amount of chances that event could happen, divided by how many chances anything could happen. Now, if I spin this spinner, 16 possibilities. Now, how many ways could I get a 9? Well, there's only one 9. So 1 over 16 is that probability as a fraction. But now to convert that fraction into a percent. Again, that's where I have to take that fraction, turn it to a decimal, which means I'm going to take 1 and divide it by 16. And then I'm going to multiply by 100%. And I end up with 6.25%. All right, now I look at B. The probability that I get at least 12. Well, again, I'm going to write as a fraction the total outcomes down the bottom. I got 16 possibilities. Now, how many ways could I get at least 12? At least 12. That means I'm including 12. Well, let's see here. 1, 2, 3, 4, and 5. 5 different ways. 12 to the 16. 1, 2, 3, 4, 5. So I got 5 possible ways that could happen. Again, converting to a percent. I take 5 divided by 16, and then I multiply that by 100%. And this time I end up with 31.25%. We're not going to do C, a perfect square. We are going to do D, though. The probability that it's not shaded. Okay, so again, as a fraction, total outcomes on the bottom. I got a 16. How many are not shaded? Well, I'm going to go count them. Let's see. I got 1 and 2, so that's 2 right off the bat. Then 3, 4, 5, 6, 7. 7 possibilities. So I got 7 out of 16 chances. Again, converting to a percent, 7 divided by 16, then times it by 100%. And this time I'm going to get 43.75%. All right, E. The probability that I get a 2 or an 11. Well, again, there's 16 outcomes. There's only 1 2 and there's only 1 11, so there's only 2 possibilities. And so as a percent, again, 2 divided by 16 times 100%, I get 12.5%. All right, F. What is the probability you get a multiple of 5? So in other words, anything that's divisible by 5 nicely. Well, again, I got 16 possible outcomes in the bottom. Well, 5 is a multiple of 5, and then 10, and also 15. Those are all multiples of 5, no other ones that are divisible by 5 nicely. So there's 3 possibilities. Let's see, again, converting that to a percent, 3 divided by 16, times it by 100%, and I get 18.75%. There we go. All right, let's try some different ones here. All right, a month of the year, number 4. A month of the year is chosen at random. Find each probability. All right, so the probability that our month starts with J. Now, again, as a fraction, I've got 12 possible outcomes. All right, and how many months start with J? We have January, let's see, June, and July. And that's it. So there is 3 possibilities. Again, converting that to percent, 3 divided by 12, and then times by 100%. There is a 25% chance that's going to happen if you choose a month at random. Let's see here. Probability that a month starts with T. All right. So again, you choose a month. There's 12 possibilities. Let's see here. Starts with T. Let's see. January, February, March, April, May, June, July, August, September, October. There is none. 0 out of 12. So I don't even have to, well, I can convert this to a percent, but I know there is no chance that's happening. A 0% chance. You can still figure it out. 0 divided by 12, then times 100%, but there's a no chance. See, we don't have calendars ready here, so we're going to cross that out. Speaking of, number 5. A letter, any letter here, from the word probability is chosen at random. Find each probability. Okay. So first off, the total possibilities. I don't know how many letters are in probability. Let's count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 letters. Some of them are the same. So we're all treating them as individual letters. But the probability of a B being chosen, there is 2 B's in probability. Now, again, converting that to a percent, 2 divided by 11, and then times 100%, I get 18%. It's a weird number. All right, the probability, we got ourselves a vowel. All right, so again, there's 11 letters. And let's see, vowels, I got 1, 2, 3, 4 of them. There's 4 vowels in probability. And so let's see here, 4 divided by 11 times 100%. Let's see, I end up with, 36.36%. There we go. Y. Well, C, sorry, I should say. Probability of getting a Y. Well, again, we have total outcomes is 11. There is only one Y. So we got 1 out of 11 chance. And as a percentage, again, 1 divided by 11 times 100%, I get 9.09%. All right. Next up, let's see here. We got a pencil box contains 5 red, 6 yellow, 8 blue, 3 orange, and 2 purple colored pencils. If one is chosen at random, find each probability. Okay, so I got to figure out first how many possible outcomes there are. So we have 5, 6, 8, 3, 2. All right, so I got to add those together. So 5 and 6 is 11, plus 8 is 19, plus 3 is 22, and plus 2 purple ones is 24. All right. So I know there's 24 possibilities here when I reach into this pencil box. Now it says, what is the probability you grab a yellow one? How many yellows are there? Let's see here. 6 yellow. So I have 6 yellows, 6 out of 24 chance. Again, converting to a percent, 6 divided by 24, then times 100%, I end up with 25%. All right, what is the probability be here of blue or purple? Blue or purple. So again, there's 24 possibilities. What I need to know is how many blue and how many purple there are, because we're going to put them together. We got 2 purple and 8 blue. So 2 purple, 8 blue, 10 possibilities, 8 plus 2. Again, converting to a percentage, 10 divided by 24, then times 100%, I get a 41. Again, going to 2 decimal places here, 0.7%. All right, now here's something a little different. What's the probability it's not orange? So again, there is 24 outcomes. Now I get to this part that's a little bit different, is that they're not orange. Well, we have 3 orange ones, which mean the rest are not orange. So there is 21 possibilities, because 24 minus 3 is 21. So 21 pencils are not orange. And so, again, converting to a percentage, 21 divided by 24 times 100%. This time I'm getting a high percentage of 87.5%. All right. One of the reasons I like probability is cards, playing cards. So you got to know some information about cards, and that's why we're going through one of these things. Is that if a card is chosen at random from a standard deck of cards, find each probability. All right. So a little information here is total outcomes. There is 52 cards in a standard deck. All right. No jokers involved, just the usual ace, king, queen, jack, 10, all the way down to 2. All right. Now, if a card is chosen at random, find the probability of a queen. Now, there is 3 suits, as we call them: hearts, spades, diamonds, and clubs. And there's a queen of each of them. So there is 4 possibilities, because we have the queen of hearts, queen of spades, queen of diamonds, and queen of clubs. Now, again, converting that to a percent. I divide my fraction times by 100%, and I get a 7.69%. There we go. All right, the next one, B. The probability that you get a red 3. So again, there's 52 total cards in a standard deck. A red 3. How many of those? You can have the 3 of hearts and the 3 of diamonds. That's it. So there is 2 possible outcomes. And so again, converting that to a fraction, it is a fraction, now to a decimal, and then to a percent, I end up with 3.85%. All right, now, probability that you have a spade. Okay. 52 cards total. Now, the probability that you have a spade, as I've mentioned before, there are 4 suits in a deck of cards. And you have spades, hearts, diamonds, trumps. And if you take 52 and you divide it by 4, you will discover that there is 13 cards. So there is 13 chances you have a spade. That's a nice way of, or you could also count that you have the ace, which is like a 1, ace to 10. So that's 10 cards. And you have your jack, queen, and king. And then again, 13 out of 52 chance. Convert that to a percentage. So 13 divided by 52 and then times it by 100%, I get 25%. There we go. All right. Last little bit here. We did one of these. It's called the complement of an event. Now, the complement of an event is the probability of an event not happening, because all we've looked at is something happening. All right. Now, since the sum of all probabilities in a sample source is 1, again, or 100%, the probability of an event not occurring is 1 minus the probability of the event happening. All right, so we can look the other way. We've looked at most of the time that we've looked at the probability happening, but now we're looking at it, hey, it doesn't happen. So for instance, number 8, if the probability that it will rain tomorrow is 3/8, what is the probability that it will not rain? It's kind of like a complement of an event is you have a glass full or a glass empty kind of situation. In number 8, I think it's a glass full. So if the probability of the event happening, so I can write that probability of rain is 3 divided by 8. The probability of no rain is the rest, which would be 5 out of 8, because there's only 8 total, right? Because your event has to add to 1. And again, if I take that fraction and convert it to a percent, again, 5 divided by 8 times it by 100%, I get 62.5%. So again, kind of a glass full, glass empty kind of situation. Last one here, number 9. If the probability that someone will win a game at the carnival is 1/24th, what is the probability that they will not win? All right, so the probability that they win is 1/24, which means, so I guess that's a glass full. The probability that they lose, well, there's 24 chances. 1 they win, it means 23 out of 24 they will lose. And so if I again convert that to a percent, first I'm going to convert it to a decimal, 23 divided by 24, and then times it by 100%. Well, unfortunately, this person, the odds that they're going to, or the percentage that they're going to lose is 95.83%. So again, that's probability. It's all about counting how many ways that things can happen, and then how many ways you want a certain event to happen. And then, of course, you need to be able to convert